Hello, and welcome to today's webinar titled One-Click HPC powered by Univa and RightScale. My name is Brett Fye, and I'm the Partner Marketing Manager here at RightScale. And I'll be introducing you to our panel momentarily, but before we do that, we'd like to start by asking the audience a few questions to help us better understand who is attending today. So if you could take a moment to answer the questions on your screen, we'd really appreciate it. All right, and those should pop up momentarily. The first question is how you are currently deploying Grid Engine today, whether in your private data center, in an infrastructure to service provider such as Amazon's EC2, or perhaps you're still investigating or evaluating Grid Engine. And we'll wait just a moment for some answers to come in. Okay, looks like the majority of you are still evaluating and investigating, but a good number have already deployed it in your private data center. That's great. Thank you. The next question is, what is your current utilization of infrastructure as a service? Are you evaluating that? Currently utilizing it for small workloads only, or using it for the majority of your workloads? All right, and it looks like answers are coming in. Okay, also it looks like most folks are still evaluating, with a few deploying large workloads and some deploying some small. Okay, thank you for that. And finally, what is your main concern with deploying to the cloud? Is it the complexity of managing systems, security and data protection concerns, or moving large quantities of data? And it looks like we've got some answers pouring in. Okay, so mostly it's the complexity that seems to be the major concern, with quite a few still worried about security, and of course some who are concerned with moving the data. Well, thank you very much for those answers, and it's good to see that we've got a nice mix in the audience today. With that, I would like to introduce you to our panel. Joining me from RightScale is Alex McClure, Business Development Manager for our ISV Partner Program. Alex has a very strong background in software engineering and distributed systems, and he'll be talking to you today about RightScale and the solution we've built with Univa. Also joining us is Bill Bryce, the VP of Products at Univa. Bill has over 20 years of experience in distributed computing, and will be talking to you today about Univa, as well as providing some best practices for HPC in the cloud. We are able to answer your questions during the webinar, so please feel free to ask using the chat window. Our Q&A panel who will be responding to your chat are Daniel Howard, our inside sales rep here, and Mike Frisch, Senior Engineer for Univa. Any questions that we don't get to during the presentation, we will try to cover in the live Q&A immediately following. To give you a preview of what we'll be covering today, we'll start by providing a brief introduction to RightScale and Univa. From there, we'll go into some basic concepts around using the cloud for HPC. And after that, we'll show you a demonstration of Grid Engine on-demand solution that we've built together, as well as dive into some best practices for HPC in the cloud. We'll leave about 15 minutes at the end for Q&A. And with that, I'd like to turn the microphone over to Alex, who will begin by introducing RightScale.
Thank you, Brett, and welcome everybody. For those of you who are new to RightScale, RightScale is a multi-cloud management platform. We have enabled and are behind the largest cloud deployments in the world, including some extremely large scaling events. One, for instance, is where we help the customer scale from 50 to 5,000 servers in under a week, and another where we helped a single customer's application scale to support over 35 million users in a single day. Now, when we talk about cloud, we're referring to infrastructure as a service, and RightScale acts as a single pane of glass to the various infrastructure as a service providers. We offer support for Amazon Web Services, Rackspace, Cloud.com, and Eucalyptus, just to name a few. When I say that RightScale is a multi-cloud management platform, that means that it encompasses orchestration, configuration management, and automation. For our customers, this enables them to perform more advanced management tasks than what they'd be able to do with only their infrastructure providers. They're able to do things like monitoring, automated alerting, escalations, and automated remedial actions. And RightScale couples this with a management layer for better visibility and control over users, groups, company systems, and even costs. We sit in the middle between infrastructure and below the application layer. And as we define it, we like to bring a level of agnostic system design and management to the cloud. And these clouds can be public, private, or even hybrid. And as a result, our customers end up having better agility, better portability, control, and security. We've been going at this for over 5 years now, and to date, our customer base of over 40,000 have launched and managed over 2.8 million servers in the cloud. To give you a sense for just how large that is, servers hosted in the cloud and managed by RightScale are responsible for nearly 3 to 4% of all internet traffic today. I want to spend a minute highlighting just a few of these customer examples that you see on the screen. I love Eli Lilly's use case. They built a virtual appliances and managed them through RightScale. But because of their regulatory requirements as a pharmaceutical company, they use RightScale to build workloads and confirm that they contain the correct operating systems, applications, data, and stacks. The Center for Biomedical Informatics at Harvard Medical School is another great example. They use RightScale's user and sub-account functionality to organize capacity and resource potential in their multi-institutional setting. These are just a couple of examples, but before spending too much time on these, I'd now like to turn it over to Bill Bryce, VP of Products at Univa, who will be talking a little bit about Univa and Grid Engine.
Thank you, Alex. So as you can see from this slide, it's just a quick introduction to who we are, who Univa really is. And we focus on optimization, and in particular data center and cloud optimization using our products and some of our management software. We've been doing this for quite a long time, approximately 10 years in the technical computing space and the cluster computing space. And as you can see, we have various products and various customers. So our products, such as Univa Grid Engine, what they do is they process massive volumes of jobs through a limited number of cluster compute resources in the shortest time. I mean, in summary, that's what Univa Grid Engine does. But it's also very flexible, and flexible enough so that you can define the most important criteria for your workload, whether that be the fastest time to complete all your jobs, or always on, completing the highest priority workload first, things like that. And Univa Grid Engine is used every single day in thousands, in fact, over 10,000 data centers all around the world, from academia, from research institutions. As you can see from the list of organizations on this slide here, people like Argonne, people like Tata, they use it every single day to solve particular, technical computing problems. So, as I mentioned, Univa is focused on optimization, but that really is a very general statement. So to be specific, you can move to the next slide on data center optimization. And in here, We're trying to make it very straightforward and simple to show you what we're really doing. And as you can see from this slide, if you have a data center with a fixed number of compute resources, it's sort of like playing a game of Tetris. You have a backlog of work that you need to do. You do need a product like Univa Grid Engine, and what it does is it moves the workload around. It decides which workload gets done first, and in a way, much like the game, it's rotating the jobs in this case so that they all fit into a nice packed manner on the machines you have in your infrastructure. So that's really what Univa Grid Engine is focused on. But if you look more on the right-hand side of this slide, what you're sort of seeing here is a very generic exponential growth curve, but this is what's happening in your environment when people are saying, I really just need more resources, and I need them now, and I need them for a particular, very computationally intensive task. So obviously the users want more than what you have today, and so what we're doing with Univa Grid Engine and RightScale is we can deliver these on-demand resources to address these issues. We're combining the in-house management of computational resources with RightScale's and Univa Cloud resources to give you sort of tons of flexibility to optimize how you want to approach running your computationally intensive tasks. So that's what I mean by optimization, optimizing the scheduling and organization of workload onto machines in a cluster environment, and also, giving you the opportunity to grow and on demand provide a much larger resource pool of computational resources if you need it. So could you move to the next slide, please? So what is Grid Engine? Well, Grid Engine is a distributed resource manager, and you can see DRM. It's definitely not a digital rights manager, but it has the unfortunate acronym as DRM. As I mentioned before, it is used in over 10,000 data centers around the world and provides job scheduling for distributed clusters. So the resources in these clusters, as you can see on the slide, were all about resource management, software license monitoring and tracking and things like that. What these resources can be is pretty much anything that you can measure. It could be memory, it could be widgets, it could be software licenses, as the slide says. But most of the time, for many of our customers, the resources represent, machines that can run work, and attributes of those machines that you're particularly interested in, like this is a faster machine, or this machine's a special one with a special type of software installed on it. So our customers buy Grid Engine primarily because of the scheduler and its flexibility. We can configure it to handle, small or huge volumes of workload, serial, parallel jobs, short jobs, long jobs, all different types of work. That flexibility allows organizations to sort of match their, their business objectives, like what do they want to do today, what do they want to do in the next month, to sort of the policy and resource selection within Univa Grid Engine, and that's how the scheduler knows what to run and when. Very flexible. Does take some time to get used to how to configure this scheduler, but we've actually made it very simple, and I think as simple as possible with the Univa and RightScale integration. So as I mentioned, resources are pretty much anything that can be measured, and the scheduler needs this resource information from machines when it's making its scheduling decisions. And that's where I'm sort of focusing on this point of software licenses. In most of our customer environments, these software licenses can be relatively expensive, and Grid Engine is focused on making sure I have the machine, I have the software license, I have the right people who have access to this hardware at the right time to get the job done. So can we move to the next slide, please? So this slide, we're going to do a breakdown of Univa Grid Engine use cases by industry. And I'll go into some detail, but I might go a little less detail on some of the other, because there's quite a lot here, as you can see on the slide. So in financial services, Grid Engine is used quite a lot in the back office processing. So at the end of day trade reconciliation, used for running things like Monte Carlo models and analysis. People use it to test out new financial algorithms, dreamed up by the quants on Wall Street. So it is used quite a lot in those scenarios. In manufacturing, that is a very broad segment of industry, but there are some highly visible places where things like Univa Grid Engine are used, such as in car manufacturers. In the different steps in the design of a car, you want to make sure you're building the right vehicle, doing the right thing. A very good example of this is, you want to crash the car, but you don't want to keep crashing physical cars. You want to crash it virtually and crashing it into different types of obstacles. You can do this, of course, in simulation, and Univa Grid Engine can be used to schedule and drive and run that simulation process. And simulation is very important in electronic design automation, where these large EDA chip manufacturing companies have long used Grid Engine in the design process. And they use it a lot, especially in the simulation and the verification stages, where you want to make sure that, did the chip that you just create, this design, does it actually work the way you expected? Is it mostly error-free? As we know, the bugs do creep in. Will it fit on the silicon? I mean, as you can imagine, it would be a massive problem if you created the best performing design and then you can't fit it on a piece of silicon. Grid Engine helps in this process, really with the whole point of running the simulation and the testing and regression to make sure you got it right. In the digital media space, tools such as Grid Engine are used for running the render farm. It's pretty straightforward. When you want what you see that goes up on the screen, runs through that render farm, image by image, scene by scene. And Grid Engine manages, which scenes get completed first, which order, all of that. In aerospace, obviously safety is of critical importance. After all, failure on an airplane could be quite disastrous. So Grid Engine is used for a lot of safety type analysis and simulations scenarios. It's also used quite a lot in things like, improving fuel economy and overall performance of an engine. Even what looks like a small increase in overall efficiency and fuel economy on a gas turbine engine or a jet engine can translate into millions of dollars over the lifetime of that airplane. And Grid Engine is also ideal for running clusters of machines, weather forecasting, science. As you can see, it's a pretty long slide. So I'll just, skip over more detail on the sciences. In life sciences, it's used quite a lot in the bioinformatics pipeline, where the workflow of running jobs through their clusters, maybe for doing genomic or proteomic analysis, things like that. So could you go to the next slide, please? And I think I'm handing this over to Alex.
Perfect. Thanks, Bill. Now, I'd like to spend a few minutes talking about why the cloud is perfectly suited for HPC workloads. And I want to do that by talking about the most important element in the whole equation, which is the human element. If you're a researcher, scientist, or engineer with a great idea, and you want to turn that idea into a successful product or solution, you've probably run into the traditional barriers of IT. Maybe it's been slow to procure or to provision servers. Or perhaps you've only had limited resources to do the work that you need to. Worse yet, maybe there was competition over those resources by various groups within your organization. These are the exact barriers that the cloud removes. With the cloud, you can provision servers instantly with the click of a button. And because it's the infrastructure provider's problem to worry about capacity, not yours, you can theoretically have access to unlimited resources. And with pay-as-you-go pricing and no upfront infrastructure costs, you aren't restrained by long procurement cycles. At the end of the day, what does that result in? Our hope is that it leads to medical breakthroughs, faster engineering feats, and overall increased productivity. Going back to the Eli Lilly example that I gave earlier, it certainly did for them. With cloud computing and RightScale, they decreased the amount of time it takes to provision and spin up a server from 25 days down to 5 minutes. And that's changing the way they think about research. So up to this point, we have been talking primarily around RightScale, Univa, Grid Engine, and some HPC use cases for the cloud. Now we want to switch gears a little bit and take you into a demonstration of what RightScale and Univa have built together, which we've called Click HPC. With our Click HPC offering, you can now deploy a Grid Engine cluster in under 10 minutes. RightScale is handling all of the server provisioning and orchestration so that after clicking the launch button, your execution hosts and queue master are all ready to begin performing your work. Bill will be demonstrating this process in more detail, but to give you the 3 basic steps for utilizing this solution, all you have to do is sign up for AWS, sign up for RightScale, and then follow the Grid Engine, the Univa Grid Engine wizard. So with that, Bill, go ahead and take it away.
Okay. Can everyone see my screen, or do we have to pass? Okay, thank you. So what you see here is that the actual login screen for the RightScale management interface. And I'm just going to log in, and this will take me to the RightScale dashboard. So it may take a few seconds for the dashboard to appear. And from here, what we see is the current status of the cloud infrastructures that are connected to the RightScale management infrastructure. We see the deployments that I've already created in my environment, and of course, help and getting started in quick macros and things like that. So as Alex mentioned, what we need to do is run the Univa Grid Engine macro. But in order to get that macro, we actually have to go to the design drop-down and move over to the multi-cloud marketplace, and in particular, go to the macros section. And over here, there are many different macros for different types of deployments and configurations. And one of them is the Univa Grid Engine Cluster Deployment macro. If we click on that, it gives us more information about the macro, in particular an obvious description, and more importantly, the pricing information and the hourly or monthly costs, how it works, and the schedule for pricing for the different size instances. So it's good to read that in detail. And once you're comfortable with that, you really just subscribe to it. And what that does is it brings it into your management environment so you can actually use it. Now, we're going to just run this macro. And from here, you get to choose the security group, the SSH key. You want to make sure that you choose one that you haven't been using before. And you run the macro. We'll give it a name. And we'll give it a AWS security group. And keep there. And I'm going to leave the number of execution nodes at the default. Now you also get to choose the instance type for your head node. In this case, it could be smaller or it could be bigger. Most people don't want a bigger one. But for the compute nodes, sometimes you do want a larger one because it's more effective to run your application on a larger type of instance. And from there, the macro will run. And it will create, as you can see here successfully, the deployment. Now if I move over to my Manage Deployments part of the interface, you will see that there are several deployments here. There's a default deployment which everyone gets. There is a Univa test deployment 2, which I just created. If I click on it, and that will bring me to more detail on this deployment. You can see it created a deployment of 5 execution hosts and 1 queue master. Now to start this up, really all I have to do is select them all and launch them. Now, much like your favorite cooking shows, I've made it much easier, and I already have a deployment in the oven. So right here, the big demo cluster. Because it does take about 10 minutes from beginning to end to get the cluster up and fully operational, and really during a demonstration such as this, it doesn't make a lot of sense to have you, watching and waiting. We already have a working cluster environment. So these nodes are fully operational. They're actually being monitored by RightScale. But the one we're interested in the most is the queue master. And so to get a console session on it, I click on this little button here, and you can see it. The tooltip pointed out that will get me an SSH session. And there we go. We're actually logged in to the head node of my compute cluster. Now, if you're familiar with Grid Engine and Univa Grid Engine, you'll know that commands such as qhost are used all the time to show you the current state of all of the hosts in the cluster. And in this case, I have my 5 nodes and my head node, and they're up and running, the memory available, the memory used, the swap. There are no jobs in the system right now. I can actually run commands across all nodes in the cluster because we've had some parallel tools built into it. So if I want to run host name, which is very trivial, if I type it right, it will give me information on all hosts in this cluster. Now, of course, you want to see it actually do some work. So we will submit a sample job into the cluster environment just to show you that the entire system is operational and up and running. So that's the queue sub command. And what I actually submitted was an array task job. So now if I do a qstat, you will see that right now they are all pending. They're queued waiting. That's what this QW means. If I do another qstat, you will see that some are running. So it already started running the first batch of small tasks, and it will just process through the rest of these jobs. So at this point, we have a fully operational cluster. We can add new users to this cluster on the fly. You can move your data up into the cluster environment or put it on a different storage volume and mount it and begin using your Grid Engine cluster. So it's quite straightforward to get to that point. And really, when you're finished with it, it's a matter of selecting them all and just shutting them all down. So that is pretty much it for the demonstration today. And who should I give the presenter back to?
Okay. Well, great. Thank you for the demo, Bill. And would you like to go into best practices for managing data in the cloud?
Sure. Just hold on one second. So, as you can see from the demonstration, it was very, very easy to create the cluster, get up and running. You have compute resources, so they're ready to do work. So the next obvious thing that is very important is how do you get your data into this environment so that you can use it and do useful work. First of all, the data can be transferred either using tools like SCP, or you could actually, if it's a larger amount of data, you could use things like the Amazon S3 tools. Once in S3, you could share that data by large numbers of compute nodes simultaneously. Or if the data set is like one big chunk of data, or you need like POSIX semantics on this data, like file level locking, it's likely better to load the data into something like Amazon EBS and then mount that on your head node and share it out using NFS. We find that a lot of our customers, rely heavily on NFS type file systems to run their work. So, putting it into EBS and mounting it and then re-exporting it does work quite well. There are some disadvantages of that because if you have a particularly large cluster, then using NFS likely will not provide the performance that you're looking for. So sharing it via S3 or some type of other parallel file system is likely the best way to proceed. For some industries such as life sciences, there are quite a lot of public data sets already loaded into Amazon. So there's no need to copy sort of your initial data set into Amazon, but you may want to move your results back up. You could likely find a data set that's already there. Finally, an important thing to remember, as you can see from the bottom of this slide, moving your data into Amazon is free. So they don't get penalized to do that. Can we go on to the next slide, please? Now we have just discussed over how you get your data into the RightScale Univa Amazon environment, but you also need your applications there in order to run the tools. Sort of take a play on that real estate mantra. Instead of it being about location, 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 it's about application, application, application. I mean that's really why you went to all this work to create this environment in the first place. So first of all, the biggest hurdle to running applications in any cloud infrastructure is not the data or that the app will run slower. It's really the licensing, especially when you get to commercial software. So some of the software vendors have adopted cloud licensing models, but others may need a little bit of a push. So, as many of the end users who I'm sure are listening, if you feel free to give them a little push if it is really important to you. If the software supports a cloud licensing model, then that's perfect because there are several ways you can run it in a cloud environment. You can use the traditional deployment strategy of installing the software on a NFS-mounted file system and then mount that file system on all of the compute nodes in the cluster. Again, works very well up to a point. Usually when the cluster gets too big, very similar to sharing your data. It may be better to do something else like use RightScale server templates to install and configure the application on each compute node in the cluster. This type of approach will require more initial front-end work, but obviously once you get this done, you have scripts that can be used throughout the RightScale management framework, and you can use them on other cloud infrastructures, and you can install the application. Hold on a second. Install the application on different, as I mentioned, different cloud infrastructures. Another straightforward approach is to upload the application to the cluster head node, the queue master, and then copy that application to all the different nodes manually and install it there. So there are different ways you can put your executables into a cloud environment. It really does come down to if it's a commercial software, what's the licensing model? How big of a cluster are you going to create? Because you could do it the very straightforward NFS way, or if you want a lot more flexibility in the future, then you would use the RightScale approach with the server templates. And I think that's it for the next slide. So I'm passing it over to Alex again.
Thanks, Bill. Now, to shift gears a little bit again, I do want to spend some time talking about security because security is a huge topic for the cloud, and we frequently get asked the question, is the cloud secure? From our poll questions earlier, many of you seem to share that same concern. So it's a broad question, of course, but if we narrow the cloud down to talk specifically about Amazon Web Services, they offer several levels of assurance. The reason why I will focus on Amazon Web Services for this webinar is because the solution that RightScale and Univa have built together is intended for now to run on Amazon Web Services. So first and foremost, their infrastructure meets several levels of security compliance. They are PCI Level 1 compliant, which means that you can even store and process customer credit card data in their cloud. They're also ISO 27001 and FSMA Low certified, which is required to run the government websites and agencies that they do on Amazon's infrastructure. They're also SAS 70 Type 2 and HIPAA, which enables companies in the health and medical space to store sensitive patient information. But of course, even the most secure entity in the world still has to have a way to let users in. So the important thing is protecting your keys and your credentials. That's why Amazon's built an entire security center which provides best practices, white papers, and additional support for achieving high security in the cloud. As an additional layer of security, RightScale also provides user management and account management capabilities to help companies achieve even greater security. We also provide infrastructure and security auditing capabilities directly from our platform. And finally, we have a broad range of partners in our ISV ecosystem who provide even further additional levels of security. Now, I know many of you have been wondering and even asking, if you run the solution, what is it going to cost you? Our goal has been to make this as easy and cost-effective as possible to run the Grid Engine on-demand solution. So the pricing structure breaks down like this. First, you'll have to pay for the underlying infrastructure costs. Like I mentioned earlier, because we started by offering support for Amazon Web Services initially, you'll be able to find the infrastructure costs on their public website. You can gain access to servers for literally pennies per hour, but you'll have a few other factors such as storage and bandwidth. An important note about bandwidth is that Amazon recently announced that all data transferred into their cloud is free of charge. Next in the pricing model, you have the RightScale subscription costs. RightScale pricing is also available on our website. And finally, you have the Univa Grid Engine on-demand component. And there's two different pricing options there, depending on if you have short, bursty workloads or steady-state usage. Pricing there begins at 2 cents per node per hour, or about $2 per node per month, depending on which plan you subscribe to. One final note about pricing. I'd like to highlight why we're offering an hourly pay-as-you-go plan. For organizations that are striving to achieve true agility in the cloud, consider this following equation. Say you have a workload that consists of 10,000 jobs. If you're running your servers in the cloud and you're paying for them hourly, you can either run, say, 2 servers for 500 hours or 1,000 servers for 1 hour, both at a rate of 10 jobs per hour. The cost will be the same, but with the first scenario, you finish in 500 hours, and in the second scenario, you finish in about 1 hour. Are there exceptions to this? Sure, you may have software licensing constraints, as Bill mentioned earlier, or maybe you have analysis that needs to be done in between each job, but hopefully you get the idea. So with that, and as we come to an end to the webinar, before we dive into a Q&A session, I'd like to just summarize some of the key points from this presentation. First, RightScale and Univa have partnered together to develop a one-click HPC solution that lets you easily and repeatedly stand up Grid Engine clusters in the cloud. It's ideal for engineering, scientific, life sciences, finance, and media processing workloads. We have 2 different pricing plans available, a pay-as-you-go hourly model or monthly pricing if you have steady-state usage. And Univa is providing their proven support for Grid Engine, while RightScale provides the system orchestration and management capabilities. So with that, let's open the floor up to a few questions. Okay, I see that we already have a few coming in. Let's start with this question from someone who asked, this wizard gives you the ability to pick which Amazon region you wanted to start your cluster in. Can you talk more about how you give users this ability? Did RightScale and Univa create AMIs in all of those regions? I can take that one. That's a great question. We actually did not create AMIs in all of the different Amazon regions. Instead, we use a key RightScale design methodology that we call server templates. Server templates are basically collections of executable scripts, and these server templates are configuring the execution hosts and the queue master. And so within the wizard, you can select where you want to run those server templates, and the RightScale management and orchestration platform takes care of standing up the complete stack. Looks like we have a question about pricing. When using Grid Engine on AWS, are we paying for the cluster resources if there are no running jobs? That's also a great question. On Amazon Web Services, you pay for your cluster resources, or essentially your EC2 servers, whenever those servers are up and running, whenever they're operational. So one way to reduce your costs is to simply turn your servers off when there are no running jobs, and to start your cluster back up again when you do want to perform more jobs. But if you do have those servers up and running, you will be paying for them from Amazon. This is another great question. I've heard that Amazon restricts users to only 20 machines. Is that true? That's actually false. With Amazon, theoretically, you can gain access to as many machines as you want within their environment. I say theoretically because, of course, there's no such thing as infinite capacity, but like we mentioned earlier, we have customers who have scaled from 0 to 5,000 servers in under a week. It's actually quite easy to increase your limit. All you have to do is fill out a form on their website to request access to more servers. That's really for your protection. It prevents malicious users from eating Amazon's capacity, and it also protects you from malicious accidental API calls. I have a few more questions. Are we supporting Amazon's GPU instances? Right now we have that capability for some of our beta customers. If that is something that you're interested in, please feel free to contact us and we can give you more information about that. We're also in beta testing for providing support for the cluster compute instance type as well. So again, if that's something that you're interested in, feel free to contact us. This is another question, has two parts. Which data centers is this supported in throughout the world? And is there any idea of having a data center in South America? Right now, Amazon has data centers throughout the world. They're located in Virginia, California, Europe, Singapore, and Japan. And so, although they don't have a data center in South America yet, they may be offering one in the future. An important note about that is RightScale ourselves, we do not provide the infrastructure. We're a management platform that lets you more easily use the infrastructure by various infrastructure providers. So once Amazon builds data centers in other parts of the world, and as we partner with more infrastructure providers, we will continue to support those as well. This is a great question. You mentioned that there are several ways to set up apps in the cloud. What happens when you shut down the cluster? Do you have to re-upload and reinstall the apps each time you want to run? That's a great question. So when you shut down the cluster and when you turn off your instances, depending on what type of instance you are using, you may lose the information on that machine. But with that said, that's why RightScale and Univa are providing several best practices so that you don't have to re-upload and reinstall all of the apps each time you want to run. There's two ways to do that, two of which Bill mentioned earlier. The first is that you can use Grid Engine's standard way of storing application profiles. And the second is to use RightScale server templates. And the beauty of that design methodology of both of them is that it saves you from having to go through the work of reconfiguring your servers and reconfiguring your systems every time you start and stop an HPC cluster. And Bill, since you talked about that earlier, do you have any other information on how users can do that in the cloud?
What was the question again? I was answering another question, sorry.
Sure. The question was, you mentioned that there are several ways to set up apps in the cloud. What happens when you shut down the cluster? Do you have to re-upload and reinstall the apps each time you want to run?
Well, you could do it that way, although that's definitely not, an ideal way of installing your apps. I'd recommend you use something like Amazon's EBS. That's what we have used in the past, and you install it on that type of volume so that you can remount it later when you start up a new cluster. Right, so start on more permanent storage.
Perfect. Perfect. Bill, from your side, have you had any good questions come in that you'd like to answer?
Sure, there's a few questions. Some simple ones from straightforward in the perspective that when using Grid Engine on AWS, are we paying for the cluster resources if there are no jobs running? And the answer is yes. The way we've designed the pricing model, as you can see, is that we're making an assumption that people would be running these servers either for bursty short-term workloads, thus the pricing the way it is, or if you are running it for a long time, it's a much different pricing scheme when you see per month. So we did account for that when we created the pricing. And it fits, the way we priced it out fits very well with the way Amazon does its billing and the way RightScale also does its billing. So that's why we did it that way. How does support work? Who do we call for support? RightScale and Univa, or Univa? You call RightScale, then you can escalate to Univa, and that is all. That's all described when I went in the demonstration to the macro, and it talked about the solution, the description, and support, and how that all works. It's all described in there. Another question was, do the Univa costs include support? And the answer is yes. I mean, when we created the solution and packaged it up, we were very sensitive that people would have questions on how to make things work for their particular environment, and that does require support. I think another question was, is Amazon EC2 the only cloud solution Univa Grid support? How about other cloud solutions that RightScale? I think that RightScale supports. The intent is to work on other cloud infrastructures that RightScale supports. I don't believe we have actually tested that yet on other cloud infrastructures. There's nothing I can see in the way we've done it that would prevent us from running on other cloud infrastructures. I'd ask the RightScale guys if they think that that's a true statement.
Yep, absolutely, Bill. And in fact, if you are interested in running in, say, a private data center powered by Cloud.com or Eucalyptus, or if you are interested in running in some of the other infrastructure providers that we support, again, I would invite you to reach out to us, and we can describe the process for getting started for that.
Okay. And do you have first-hand knowledge of the MathWorks licensing structure for your environment? I'm not sure if that's a question. I guess it's a question for MathWorks licensing for what we've created in Amazon with Univa and RightScale. I don't have first-hand knowledge of that right now. That's a good question. We'd have to take that offline and get a better response for this particular question. And then more questions on the support side. Is there a single point of entry for support? Is it a portal at RightScale? Is it a portal at Univa? So I can definitely address the portal at Univa part of the question. There is even as I described, when you go to that macro and you include it in your environment, it does have information in there where you can log into Universe support portal and log issues with Univa Grid Engine. In terms of RightScale, can someone on the RightScale side answer that? I know there is a portal, but just...
Absolutely, Bill. So within RightScale, for all of our customers, we do offer premium support, and there are many ways to contact support. We provide telephone and email support. We also have more of a self-service support portal website on our on the RightScale website as well. So if you do go to our website and you go to our support center, you'll also find information for our partners, and in particular for Univa's Grid Engine offering. Within that support portal, you can access things like the common use cases, as well as all of the support documentation for getting started. That support documentation describes common operations that you would do on your cluster. It describes what all of the server templates and scripts do, and it also provides frequently asked questions and answers as well. But like I mentioned, that's just the self-service support portal on our website. If you do have questions or support questions around RightScale or the cloud or even this solution, you can contact our support team, and we have a short turnaround for our SLA. So many different levels of support are available. A couple more questions that we've had come in on our side is this environment for Unix and Linux only, as was demonstrated in the demonstration? Bill, would you like to take a stab at that one?
Sure. Today it is for Unix and Linux and is running in a Linux environment, as you saw on the demonstration. Univa Grid Engine does run on Windows environments, but we do not have that packaged up in a solution in a cloud infrastructure such as this.
Okay, great. And Bill, do you have any more questions coming in on your side?
No, I don't see any more questions yet.
All right. Well, as you can see on the slide, if anyone in the audience does have further questions, in addition to the ones that we answered, feel free to contact us, either RightScale or Univa. This webinar will be or has been recorded and will be published to our website shortly. And you can access that at rightscale.com/webinars. In the future, we'll also be releasing a white paper that includes some of the best practices that we talked about. You'll be able to find that in the white paper section of our website, and you can also contact us for that as well. Thank you everyone for joining today, and we hope you have a great rest of your day.